Hello everyone, thank you for stopping by. My name is Bino, and in this video we'll integrate the following functions using various integration techniques. For our first question, we have to integrate sec squared x multiplied by the square root of tan x raised to the power 5. In this case, we have the integral of g of f of x multiplied by the derivative of the f of x dx. So rearranging our integral, we have the integral of sec squared x multiplied by the square root of tan x raised to the power 5 dx. And as we can see, the derivative of this tan x is equal to sec squared x. So we can use the U sub method. So we are going to let u to be equals to tan x, and the derivative of the u with respect to x will be equal to the derivative of the tan x, which is equal to sec squared x. When we multiply both sides of the equation by dx, the du will be equals to sec squared x dx. So our integral in the form of u, so we'll have the integral, but first let's rearrange our integral. So we have the square root of tan x raised to the power 5, and we multiply this by the sec squared x dx. So in the place of the sec squared x dx, we are going to substitute the du, because the du is equal to the sec squared x dx, and this will be equal to the integral. So in the place of the tan x, we are going to substitute the u, because the u is equal to the tan x, and since the tan x is raised to the power 5, even the u will be raised to the power 5. And in the place of the sec squared x dx, we are going to substitute the du, and we rearrange our integral. So we have the integral of, so we remove the square root and we express it as u to the power 5, and we divide by the 2 from the square root du. Then the integral of u to the power 5 over 2 will be equals to u to the power 5 over 2 plus 1 divided by 5 over 2 plus 1 plus our constant c. We have u to the power 5 over 2 plus 1, which will be equals to 7 divided by 2. In the denominator, 5 over 2 plus 1 will be equals to 7 divided by 2 plus our constant c. And in the place of the u, we substitute back the tan x. So we have tan x raised to the power 7 divided by 2. This is divided by the 7 divided by 2 plus our constant c. We can choose to simplify this, and when we simplify this, this will be equals to the 2 multiplied by the square root of tan of x raised to the power 7 divided by the 7 plus our constant c. And this will be our answer for our first question. For our second question, we have to evaluate the integral of ln x divided by x squared dx. And since the derivative of the ln x is not equals to 1 over x squared, and the derivative of 1 over x squared is not equals to ln x, we can't use the U sub method. We have to use integration by parts. But before we can use integration by parts, we rewrite our integral as the integral of ln x, and we take this x squared from the denominator to the numerator, and the exponent is going to change sign from positive 2 to negative 2. And the formula for integration by parts, we have the integral of u multiplied by dv, which is equals to u multiplied by v minus the integral of v multiplied by du. This part of the formula for integration by parts correspond with our integral. So we have the u multiplied by the dv corresponding with the ln x multiplied by x raised to the power negative 2. So one of the function between the ln x and the x raised to the power negative 2 will be equals to u, and the other function will be equals to dv. We have to determine which will be equals to u and which will be equals to the dv between the ln x and the x raised to the power negative 2. We do that by the aid of the isolate rule. So the isolate rule has I, L, A, T, and E, where the I stands for the inverse trigonometric function, and the T stands for just the trigonometric function, and the L stands for the logarithmic function, while the A stands for the algebraic function, and the E stands for the exponential function. The ln of x is a logarithmic function represented by the letter L, and the x raised to the power negative 2 is an algebraic function represented by the letter A. On this isolate rule platform, the first letter between the L and the A will represent the function, which will be equals to the u, and the other letter will represent the function, which will be equals to the dv. The first letter that we come across going to the right is the L, and the other letter is the A. So the L represents the logarithmic function, the ln x, and the A stands for that x raised to the power negative 2. It's representing the x raised to the power negative 2. So the L came first, so the ln x will be equals to the u, and the A came later, so the x raised to the power negative 2 represented by the A will be equals to the dv. This formula for integration by parts is du, and we only have the u. So in order for us to get the du, we differentiate the u. So the derivative of the ln x, which is the u, will be equals to 1 divided by x. And in the formula for integration by parts, we have the v, and we only have the dv. So in order for us to get the v from the dv, we have to integrate the dv. So the integral of x raised to the power negative 2 will be equals to x raised to the power negative 2 plus 1, which is equals to negative 1, divided by the negative 2 plus 1, which is equals to negative 1, be equals to the negative. We take the x raised to the power negative 1 from the numerator to the denominator, and its exponent will change sign from negative 1 to positive 1. For integral of ln x multiplied by x raised to the power negative 2 dx will be equals to the u multiplied by v, and we have our u as the ln x, and the v is equals to the negative, so we push that negative and we write it there, negative 1 over x, and as the integral of the v multiplied by du, our v is equals to negative 1 over x, and that negative multiplied by this negative will be positive, and we have that 1 over x, and our du is equals to 1 divided by x dx. This will be equals to negative ln of x divided by the x plus the integral of 1 divided by x squared dx. We have the negative linear x divided by the x plus the integral, the x squared. We move it from the denominator to the numerator, and this will be equals to x raised to the power negative 2 dx. And finally, we integrate the last part. The integral of x raised to the power negative 2 will be equals to x raised to the power negative 2 plus 1 divided by negative 2 plus 1 plus our constant c. From here, it's just a matter of simplification. We have the negative ln of x divided by x plus x raised to the power negative 2 plus 1 will be equals to negative 1, and negative 2 plus 1 in the denominator will be equals to negative 1 plus c. We can leave our answer here, or we can continue with the simplification process where we take the x raised to the power negative 1 from the numerator to the denominator, and the exponent changing sign from negative 1 to positive 1, and this positive multiplied by that negative will be negative plus our constant c, and this will be our answer for our second question. For our third question, we have to evaluate the integral of x plus 3 divided by the x squared minus 2x plus 1, and since the power in the denominator, the x squared, is greater than the power in the numerator, we have to use partial fraction decomposition. But before we do that, let's factorize the denominator, the x squared minus 2x plus 1. We open our parentheses. The factors of the x squared is x, and we take this sign, we drop it to the first parenthesis, and the sign that we put there, when we multiply it with this sign, it should give us that sign over there, the positive. So negative multiplied by the negative will be equals to the positive, and the factors of 1 will be equals to 1 and 1. And this will be equals to x minus 1 multiplied by the x minus 1 will be equals to x minus 1 squared. So our integral will be equals to the x plus 3 divided by the x minus 1 squared dx. And as we can see, we have repeated the linear factors in the denominator. For now, let's drop the integral and we focus on simplifying the x plus 3 divided by the x minus 1 squared, and this will be equal to the a divided by x minus 1, and since we have repeated linear factors in the denominator, this will be plus b divided by x minus 1 squared. Integrating the left hand side will just be the same as integrating the right hand side. But first, we have to determine the numerical values of the constants a and b. So we have the x plus 3 divided by x minus 1 squared. From here, we multiply each and every term by x minus 1 squared. And what we do on the left, we also do on the right. So each and every term on the right hand side will be multiplied by the x minus 1 squared. So the x minus 1 squared will be multiplied with the a and divided by the x minus 1 plus, we multiply every term by the x minus 1 squared, and this will be multiplied by the b divided by the x minus 1 squared. and that x minus 1 squared and that x minus 1 squared will cancel out, and that x minus 1 squared and that x minus 1 squared will also cancel out, and one of the x minus 1 squared in the numerator will cancel out with that x minus 1 and will be left only with 1x minus 1 multiplied by the a. So on the left hand side we have x plus 3, and this will be equals to the x minus 1 multiplied by the a plus b. So since we have to determine the numerical values of the a and b, so this side will determine the value of the b. So in order for us to determine the value of the b, we let x to be equals to any number. But if we can let x to be equals to 1, that 1 minus 1 will be equals to 0, and the 0 multiplied by the a will be 0, and this will give us an opportunity to determine the value of the b. So in this equation, we substitute 1 for x. Where there is x, we substitute 1. One plus 3 will be equals to 4. 1 minus 1 will be equals to 0, and the 0 multiplied by the a will be 0, and our b will be equals to the 4. So since the b is equals to 4, on this side we determine the numerical value of the a. So we can let x to be equal to any number, so let's choose a smaller number like 0. So in this equation we are going to substitute 0. So we have 0 plus 3 will be equals to, where there is x, we substitute 0, and since we determined that the value of the b is equals to 4, so in the place of the b we'll just go right ahead and substitute the 4. 0 plus 3 will be equals to 3, and we take this positive 4 to the left, it will change sign from positive 4 to negative 4. 0 minus 1 will be equals to negative 1, multiplied by the a will be equals to negative a. So 3 minus 4 will be equals to negative 1, which will be equals to negative a, multiplying or dividing both sides of the equation by negative 1, and our a will be equals to 1. So we determined the numerical value of the a and b. So let's copy and paste. Like I said, integrating the left hand side with respect to x will just be the same as integrating the right hand side with respect to x. So we paste, and we have determined that the a is equals to 1, and that the b is equals to 4. So we integrate this with respect to x. The integral distributed, so we have the integral of 1 divided by x minus 1 dx plus the integral of the 4 divided by x minus 1 squared dx. The integral of 1 divided by x minus 1 will be equals to the ln of x minus 1 plus the integral, so we have the integral of 4 divided by x minus 1 squared. We are going to let u to be equal to x minus 1, and the derivative of the u with respect to x, the derivative of that x will be equals to 1, and the derivative of the negative 1 will be equals to 0. We multiply both sides of the equation by the dx, and our du will be equals to the dx. So we can take this 4 out of the integral since it won't affect the integration process, and in the place of the x minus 1 we are going to substitute the u but the x minus 1 is raised to the power 2, so even the u will be raised to the power 2. And we said that the du is equal to the dx, so in the place of the dx we substitute the du, and we express this as 4 times the integral of the u squared. We take it from the denominator to the numerator, and the exponent will change sign to negative 2. So the integral of u raised to the power negative 2 with respect to u will be equal to u raised to the power negative 2 plus 1 divided by the negative 2 plus 1 u raised to the power negative 2 plus 1. Negative 2 plus 1 is equal to negative 1. Negative 2 plus 1 is equal to negative 1, and this will be equal to negative 4 times u raised to the power negative 1. But we can take the u to the denominator from the numerator, and the exponent will change sign from negative 1 to positive 1. We have the plus c. So in the place of the u, we substitute back the x minus 1. So finally, this will be equal to negative 4 divided by the x minus 1 plus c. So the integral of 4 divided by x minus 1 squared will be equals to negative 4 divided by x minus 1 plus c, and this will be equals to the ln of the x minus 1 plus, we can distribute this negative to the denominator, and this will be equals to 4 divided by 1 minus x plus our constant c. For our last question, we can see that the power in the numerator, the x to the power 3, is greater than the power in the denominator. Remember, for our third question, the power in the denominator, the x squared, was greater than the power in the numerator, and we used partial fraction decomposition. So in this case, since the power in the numerator is greater than the power in the denominator, we have to use the long division method. So for this question, we have to evaluate the integral of 2x cubed plus 7x squared plus 2x plus 9, and this is divided by the 2x plus 3. So we are going to use the long division since the power in the numerator is greater than the power in the denominator. For now, we drop the integral and we focus on simplifying the integrand using the long division method. This side we will have the 2x cubed plus the 7x squared plus 2x plus 9. We can have this map by the side, which we start with the division, the multiplication, the minus, and the drop down. We start by dividing, so the 2x cubed divided by the 2x will be equals to x squared. And now that we divided, we focus on the multiplication, so we'll have this x squared multiplied by the 2x plus 3. The x squared multiplied by the 2x will be equals to 2x cubed, and the x squared multiplied by the positive 3 will be equals to positive 3x squared. Now that we multiplied, we focus on minusing, so the 2x cubed minus the 2x cubed will be equals to 0. The 7x squared minus the 3x squared will be equals to positive 4x squared, and we have minus, and now we drop down, so we are going to drop down that positive 2x. Now that we dropped down, we focus on dividing. the 4x squared divided by the 2x will be equal to positive 2x. We have divided. Now we focus on multiplying. The 2x multiplied by the 2x plus 3. So the 2x multiplied by that 2x will be equal to 4x squared. And the 2x multiplied by the 3 will be equal to positive 6x. So we have multiplied, and now we come and we minus. So 4x squared minus 4x squared will be equal to 0. 2x minus 6x will be equal to negative 4x. So we have minus, and now we focus on the drop down. So we drop down that positive 9. So we have dropped down. Now we divide. So the negative 4x divided by the 2x will be equal to negative 2. So we divided. Now we focus on multiplying. So the negative 2 multiplied by the 2x plus 3. So negative 2 multiplied by the positive 2x will be equal to negative 4x. Negative 2 multiplied by the positive 3 will be equal to negative 6. So we have multiplied, and now we minus. So negative 4x minus 4x will be equal to 0, and the 9 minus 6 will be equal to positive 15. So there is nothing to drop down, so we are done with the minusing. So the remainder will be equal to the 15. So our remainder is equal to 15. So now we have this part we have the x squared plus the 2x minus 2. So we have the integral of this, and remember we also had a remainder of 15, of positive 15, and this remainder we divide it by the 2x plus 3. So this will be divided by the 2x plus 3 dx. So integrating the 2x cubed plus the 7x squared plus 2x plus 9 divided by the 2x plus 3 will be the same as integrating the x squared plus 2x minus 2 plus 15 divided by the 2x plus 3. The integral of the x squared will be equal to x to the power 2 plus 1 divided by the 2 plus 1 plus the integral of 2x will be equal to 2 multiplied by x raised to the power 1 plus 1. This is divided by the 1 plus 1, and the integral of the negative 2 will be equal to negative 2x plus the integral of 15 divided by 2x plus 3, which will be equal to 15 divided by 2 multiplied by the ln of the 2x plus 3 plus our constant c. So if you are wondering how we got this, if you can integrate the 15 divided by the 2x plus 3 by inspection, you can use the U sub method, where we let the u to be equals to 2x plus 3, and the derivative of the u with respect to x will be equals to the derivative of the 2x, which is equals to 2, and the derivative of the 3, which is equals to 0, multiplying both sides of the equation by the dx. Then the du will be equals to 2 multiplied by the dx, and we only have the dx there, so let's make dx the subject of the formula here. So we have du divided by the 2, which will be equals to the dx after we divide both sides of the equation by the 2. So our integral will be 15 divided by, in the place of the 2x plus 3 we substitute the u, and in the place of the dx we substitute du over 2. We can take the 15 over 2 out of the integral, and we'll be left with 1 over u multiplied by the du, and the integral of 1 over u will be equals to the ln of u plus the constant c, and we take back the 2x plus 3 in the place of the u, plus the constant c. Finally, this will simplify to x raised to the power 2 plus 1, which is equal to 3 divided by 3, plus 1 plus 1 is equals to 2. So this 2 and that 2 will cancel out. X raised to the power 1 plus 1, which is equals to 2 minus 2x plus 15 divided by 2 multiplied by the ln of 2x plus 3, and we have our constant c. So this will be our answer for the last question. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like and share this channel with your fellow mates.